interruption cost. So here we were finding out, So here we were finding out expansion and compression of the signals, which is very important. So x of 3t means we are compressing the signal by 3 unit. As I've already said that here it was -1. Okay. So we have to divide each indices by 3 in the case of x of 3t. Now x of t by 5 is we have to multiply each indices by 5. We have to multiply each indices by 5. So there were -1. -1 into 5 is -5. Here it was 2. So 2 into 5 is 10. So x of at means divide by a. X of t by 5 is equal to multiply by 5. Now x of minus t is time reversal. Rotate the graph about y-axis. It's a time reversal. Wherever there is 2, it will become -2. Wherever there is -1, it will become 1. And you have to reverse the graph as well. It means you have to rotate the graph as well around y-axis. Now x of t minus 3, that is add 3 units to all the indices. So if we add 3 to -1, it will become 2. If we add 3 to 2, it will become 5. The graph will remain same. X of t plus 5 means subtract 5 from all the indices. So if we subtract -1, it will become -6. If we subtract 2, it will become -3. Okay. So for the signal given below, we have to find x of t minus 6. X of t minus 6 is simple, that is add 6 to all the indices and then print the graph as it is. We have to copy the graph as it is after adding 6 to all the indices. X of 2t plus 1. X of 2t plus 1. So what we are doing? We are doing in the case of x of 2t plus 1, first we are subtracting 1 from all the indices and then we are scaling it by 2. Means we are compressing it by 2. Okay, so first we have to subtract 1 from in this question. First we have to subtract 1 and then divide by 2. So you will get the resultant graph as like this. X of 5 minus t can be written as x of minus t plus 5. This means first subtract 5 from all the indices and then reverse it and then do time reversal. So subtract 5 from all the indices and then do time reversal. This is what the time reversal. Now x of minus t minus 2. Now add 2 to all the indices. Here add 2 to all the indices and then do time reversal. First add 2 and then do time reversal. Now x of t and x of minus t. Where is x of t? This is x of t. How we can find out x of minus t? By rotating it about y-axis. After rotating it about y-axis, we will get graph something like this. After rotating it about y-axis, we will get graph something like this. Now add these two quantities. From -2 to -1, it is 2. Okay. From -1 to 0, the slope is increasing. and here from minus 1 to 0 it is constant. So we can check the slope is increasing to 2. From 0 to 1 the slope is decreasing. From 1 to 2 it is constant as 2. X of t, x of minus t, x of t, x of minus t. Now sketch x of t is equal to u of t plus 1 minus 2 u of t minus 1. So u of t plus 1 is starting from minus 1 minus 2 u of t. First draw 2 u of t, then draw u of t minus 1. Now from minus 1 to 0 it is 1, it is 0, it is 0. So 1 minus 0 plus 0, as minus 0 plus 0 is cancelled out, so the resultant value is 1. That's how we will add and subtract. The way we are adding and subtracting in the case of algebraic expressions, same way we have to do here also. From 0 to 1, let's say from 0 to 1, it is 1 minus 2, because here it's minus, here it is minus. 1 minus 2 plus 0, the 1 minus 2 is minus 1, plus 0 is minus 1. So it is minus 1. From 0 to 1 it is minus 1. At 1 it is 1 minus 2 plus 1, which is 0. So the resultant graph will look like this. You can try it out. X of t is equal to r of t plus 2 minus r of t plus 1 minus r of t minus 1 plus r of t minus 2. We have to plot it. Okay, we have to plot this thing. So r of t plus 2 is starting from minus 2, the slope is 1. Minus r of t plus 1. First just draw the slopes. So starting from minus 1 and the slope is minus 1. Minus r of t minus 1 is starting from 1 and the slope is minus 1. Plus r of t minus 2 starting from 2 and the slope is 1. So as it is going like this, so we have to stop it at minus 1. What we will do? We will add these slopes. Slopes are being added. Slopes are being added. So 1 minus 1, from minus 2 it is going, the slope is 1. At minus 1, the minus 1 slope is added to plus 1. So the slope is 0. So here from minus 1 to 1, from minus 1 to 1, the slope is 0. At 1, the minus 1 slope is added. So if in 0 the minus 1 slope is added, the slope will become minus 1. The slope will become minus 1. So here it is minus 1. Then at 2, plus 1 slope is added. If plus 1 slope is added, the slope from 2 onwards, the slope will become 0. That's how we have to plot a graph. Now discrete time signals. U of n, u of minus n. As u of n starts from 0 to infinity, u of minus n starts from minus infinity to 0. If we will add these two things, then at 0 we will get value as 2. Their amplitude is 1. Here the amplitude is 1 because no coefficient is given before u of n. Here the amplitude is 1 because no coefficient is given before u of minus n. If we will add these two things together, at 0 the value is 1. Here also at 0 the value is 1. So 1 plus 1 is 2. At 0 we are getting 2. U of n plus u of minus n minus 1 is equal to 1. We have to prove it. How? U of n starting from 0 to infinity. U of minus n minus 1 starting from first draw u of n. Then add 1 to it. First draw u of n and then adding 1 to it. We will get a signal somewhat like this. And then reverse it. We will get a signal somewhat like this. When we will add these signals, we will get as 1. Now what we will get? We will get as 1. Like in continuous time signals, u of t plus u of minus t is equal to 1. But in discrete time signals, it is not the same case. We will get 1 as when u of n and u of minus n minus 1 both are added together. Then only we will get 1. U of n minus 2. We have to plot u of n minus 2 and u of n plus 2. Very easy. In the case of u of n minus 2, plot u of n and add 2 to all the indices. U of n plus 2. Plot u of n and then subtract 2 from all the indices. You have to just print the graph. There is no change in amplitude. U of minus n. U of minus n. First draw u of n and then take the time reversal. The graph will look like this. U of minus n plus 2. Add 2 to all the indices. So now 0 will become 2. Minus 1 will become 1. Minus 2 now will become 0. And minus 3 will become minus 1 after adding 2 to all the indices. So now u of minus n plus 2 is starting from minus infinity ending at 2. U of minus n minus 2. Subtract 2. Subtract 2 from all the indices. Subtract 2 from all the indices. So this is what 0 will become minus 2, minus 1 will become minus 3, minus 2 will become minus 4 and minus 3 will become minus 5. Minus 3 will become minus 5 after subtracting 2 from all the indices. Now the graph is from minus infinity to minus 2. Whenever the time reversal is already done, and after that we are adding or subtracting, like for example, if there were u of n minus 2, then we have to add 2 to all the indices. But if it is u of minus n minus 2, then we have to subtract 2 from all the indices. Understand the difference. If there is u of minus n plus 2, we have to add 2 to all the indices. But if there is u of n minus 2, I have written here u of n minus 2, then you have to add 2 to all the indices. Same way when there is, already being explained. Now u of t, we have to write the value of this graph. So u of t, u minus u of t minus t plus r of t minus t, because the slope is 1, plus 1 by t r of t minus t, because here the slope is 1 by t. Now to have the constant slope, or to have the slope as 0, then subtract the same slope at r of t minus 2t. As we know that r of t is equal to t times u of t. So how we can write this expression? Same as u of t minus u of t minus t 1 by t into t minus t u of t minus t minus 1 by t minus 2t u of t minus 2t. Use this relation. A signal x of t is non-zero for minus 1 to 2, okay, and 0 elsewhere. Then the signal y of t is this. We have to apply principle at x of t. Then the signal is non-zero for the duration of. So first let assume that x of t is this signal, which is non-zero from minus 1 to 2. Now apply the principle. What principle is this? First, subtract 1 from all the indices. Subtracting 1 from all the indices, we will get a signal like this. Now, what we have to do? Expand by 2. Expand by 2. Now expand by 2. We will get this signal. Then there is time reversal. Then there is time reversal. Time reversal means rotate about y-axis. Minus 2 will become minus 2, minus 4 will become 4, and the graph reverses. And then the amplitude multiply by 2. So this is a final signal. The signal duration is 6, which is non-zero from minus 2 to 4. It is non-zero from minus 2 to 4. And the duration is 6. Or time reversal and time shift do not change the duration. Only time scaling changes the duration. So what is the scaling here? Scaling here is expand by 2, multiply by 2. So multiply this duration by 2. So the duration is from minus 2 to 4. Duration is 6. Or we can also do, there are 3 methods to do the same question. 2 minus t divided by 2. It is from minus 1 to 2. We are taking only the bracket part. So x of t. So t here is from minus 1 to 2. So minus t is from minus 4 to 2. Solve this, you will get that t belongs from minus 2 to 4. The duration is 6 and the limits are from minus 2 to 4.